Hi all. Today we can study Mason's gain formula, which is used to find the overall transfer function of a system. Now, Mason's gain formula. It is used to calculate the overall transfer function of the system. Mason's gain formula is given by in order to find the overall transfer function is equal to sum of k, pk delta k by delta. Cs is the output, Rs is the input node. Transfer function, it is also known as gain, is given by this expression pk delta k by delta. K is the number of forward paths. Suppose there are two only two forward paths. Then this expression will become P1 delta 1 plus P2 delta 2 divided by delta. 3 forward paths, then the expression will become P1 delta 1 plus P2 delta 2 plus P3 delta 3 divided by delta. Pk is the forward path gain in each case, and delta, what is delta? This delta is equal to 1 minus sum of all individual loop gains. First we have to find all the individual loops and find its loop gains. Sum of all individual loop gains plus sum of gain products of all possible combination of two non-touching loops minus sum of gain products of all possible combination of three non-touching loops, etc. And delta k, we have to calculate delta k by the same expression, but here we have to remove the loops which are touching the kth forward path. We have to remove the loops which are touching the kth forward path. Take the remaining loops. We can do one problem, then you will get a clear idea. Consider this as signal flow graph. We have to find the overall transfer function. First step is identify all the forward path. How many forward paths are there? Y1, Y2, Y3, Y4, Y5. Same signal flow graph, Y6. That is one forward path. Another forward path is Y1, Y2, Y3 along this branch, Y5, Y6. So these are the so two forward paths are there. So k is equal to 2. First forward path, we can take this as first path. So let it be like this. And its gain is A, B, C, D, E. And second path is along this branch, and its gain is A, B, G, E. A, B, G, E. The forward path gain is G. And then identify all the loops. This is one loop, this is another loop, this is another loop, this is another loop. Altogether there will be 5 loops. That is Y2, Y3, Y2, Y3, Y3, Y5, Y3, Y3, Y4, Y5, Y3, then Y4, Y5, Y4, Y4, then this Y5. Okay, so 5 loops. And what about the loop gain in each case? This is forward path gain, first forward path gain, second forward path gain, that is P1 and P2. Then 5 loops. This is Y2, Y3, Y2. Its loop gain is Bj. Y3, Y5, Y3. Its loop gain is Gh. Y3, Y4, Y5. Its loop gain is Cd, H. Similarly, find all the loop gains. So loop gains are L1. For the first loop it is Bj, second loop it is Gh, Cdh, Di and F. Loop gains of 5 loops. And number of two non-touching loops, it is equal to 2. So first pair is this y2, y3, y2 and y4, y5, y4 one pair. Next pair y2, y3, y2 and this loop y5, y5. So take its gain product of first non-touching. So L1 and L4, that is Bj into dA. That is sum of gain products of all possible combination of two non-touching loops. Possible combination of, so first combination is this, take sum of gain products. So it is Bj into dA. And this, for the second case it is Bj into F. L1, L5, gain product. Higher number of non-touching loops, that is more than 2. It is that is sum of gain products of all possible combination of 3 non-touching loops. There are no such combination. So only this much. Now substitute all the values. This is the expression for delta. Delta is equal to this much. So delta is equal to 1 minus sum of all individual loop gains. So these are the individual loop gains. Take the sum plus sum of gain product of all possible combination of two non-touching loops. Sum of gain product. First non-touching loop pair gain product is BJDI. Second it is BJF. Gain products. Gain products are, now the gain products are BJDI and BJF. Sum of. So take the sum of these two, BJDI plus BJF. Then remaining is 0. So only that much. So delta is equal to 1 minus sum of individual loop gain plus sum of gain product of all possible combination of two non-touching loops. So this and this, take the sum. So that is delta. Now what about delta 1? There is no loop which is non-touching to the first forward path. First forward path, all the loops are touching into the first forward path, and in the second case also all loops are touching in the second forward path also. So there is no loop which is non-touching to the first and second forward path. Therefore in this expression only one is there, not delta 1 and delta 2 is equal to 0. Delta 1 and delta 2 is equal to 1. This one is there in the expression, this one is there. So delta 1 and delta 2 is equal to 1. All the loops are touching in both forward path. So two forward path, therefore it is equal to P1 delta 1 plus P2 delta 2 divided by delta. P1 first forward path, that is ABCDE, second ABGE. So write that ABCD into 1 plus ABG into 1 divided by 1 minus delta, sum of all individual loop gains plus sum of gain products of all possible combination of two non-touching loops. So this is the transfer function and that is the answer. Thank you.